In problem 85, three objects are connected by strings that pass massless, frictionless pulleys. The objects move, and the coefficient of kinetic friction is 0.100. What is the acceleration of the objects? Find the tension in each of the two strings. Our first step is to create a free body diagram of all the forces acting in the system. As you can see, the weight of the first and the third masses are pulling downward, while the tensions of the two strings are pulling upward towards the pulleys. The weight of the second mass is creating a normal force perpendicular to the surface. We predict that the system will accelerate towards the larger mass of 25 kilograms, and thus kinetic friction will move in the opposite direction. You can calculate weights of each of the masses as shown. We will calculate acceleration through the expression A is equal to the summation of the forces over the summation of the masses. Our second step is to find acceleration. First, we have to find the summation of the forces in the x direction. We find that because the system will accelerate towards the third mass, we will say that the weight of the third mass minus the weight of the first mass going in the opposite direction minus the weight of the frictional force also going in the opposite direction. Rewritten, this is expressed as MA is equal to weight of the third minus the weight of the first minus the coefficient of kinetic friction times normal force over mass. We plug in our numbers and find that acceleration is equal to 0.6 meters per second squared. Our next step is to find both the tensions of each of the strings. In the first situation, tension 1 is going against acceleration of the system. So you have to include that the weight plus the mass times acceleration is equal to the first tension. The mass is 10 kilograms. So you end up with 10 kilograms times 0.6 meters per second plus 9.8 meters per second, the acceleration due to gravity. You find that the tension of the first string is 104 newtons. Our last step is to find the tension of the second string. Unlike the first, the weight of the third mass is going with the system, while along with the acceleration. So you have to subtract the acceleration from the weight, the net force from the weight to get your total tension. So you have mass times gravity minus mass times acceleration. In this case, you're using 25 kilograms as your mass. You end up with a tension that is equal to 230 newtons.